I promised you in one of the previous videos that I'll explain you the try catch finally exception handling system in Python. So let's look at some examples before we go directly to that, right? So let's understand this. So if let's assume if I have an error like this, so here this is syntax error, right? Because I don't have the colon here, right? So whenever there is an error like this because of syntax or because of some mathematical operations, we'll see some types of errors, right? Because of some logical errors, Python gives you an error. So here it clearly says that it's a syntax error and the syntax is invalid syntax. So let me introduce you some simple terminology. Whenever an error happens, the Python interpreter raises an error. So there is actually an error handling module in Python which says as soon as it raises an error, right? The Python's internal error handling module takes care of it and says, okay, here I have an error and what type of error do I have? There could be many types of errors. There could be errors because you're trying to open a file that doesn't exist, or you're trying to import a module that the system could not find, or you're dividing by 0, right? Look at this example. When I say 1 by 0, it immediately raises an error saying it's a 0 division error, integer division or modulo by 0. And hence it's raising this type of error. Okay, similarly, if I'm trying to open a file called test.txt, which doesn't exist here, right? It again raises an error. The error is called IO error here. And the description says that no such file or directory. This is called the error type. This is called the error type, right? This is called the error type, and this is the error description. This is the error description. Okay, this is the error description. Now let's look at some simple ways. So there are a lot of built-in Python exceptions. So you can, if you just say dir __ built-ins, these are all the types of errors that Python can handle. Like just look at it. There is an arithmetic error, there is an assertion error, attribute error, base exception. There are thousands of exceptions. There is an IO error, there is an import error, import warning. All these are types of errors that Python can automatically handle. Now having known that, now how do we handle them gracefully? Okay, let's take some simple example so that we understand it. I would prefer to walk you through this example. So here I'm saying, okay, import sys is the module through which you can get all of these try catch and everything gracefully working. I've created a list of 3 elements: a character B, numerical value 0 and numerical value 2. Now imagine if I'm trying to divide 1 by B, or 1 by 0 or 1 by 2. This is obviously not valid. This is also not valid because you can't divide an integer by a character. You can't divide anything by 0. This is valid. This is not valid. These two are exceptions, right? So let's look at some simple example. So what I've done, the 2 major differences you'll see is this words try and except. So this is called the try block. This is called the try block of code. It's called a block because you have the colon here, like just like if else or for or anything. And this is called the exception block, the except block of code. So what I do is to handle all these errors very gracefully, what I do is this. So for entry in list, so I'm calling each element in list as entry. Okay, first I print the entry and then I try to compute r equals to 1 by int of entry. When I do this with B, so what happens? My first value is B, right? It says the entry is B. This is printed properly. Now when I say 1 by entry 1 by B, of course it makes no sense, right? You can't divide an integer by a character. And it raises an error, right? It raises an error. But unlike what we have seen till now, it doesn't stop there. So what happens is as soon as it raises an error, it goes to the except block. As soon as this raises an error, it directly jumps to the except block. And errors are handled. So errors are handled gracefully. Errors are handled gracefully in the except block. Here I am saying oops. Okay. And this gives me system.execution_information 0 tells me what type of error occurred. So as soon as this happens, it prints instead of stopping. See, imagine if I didn't have the try catch, as soon as it comes with this error, it will simply block. It will simply block, just the way you saw earlier, right? As soon as an error happens, it simply stops executing there. But using try and catch, you can still have the program run and handle all these errors much more gracefully. Okay, so let's look at it. So as soon as you get 1 by b, it says, oops, the error is called value error, because the value that you have here, the value of b, makes no sense at all. The value is b, it makes no sense. And as soon as, so the way it happens is, as soon as an error occurs, it goes into the except block, anywhere in the try block, wherever an error occurs, it directly jumps to the except block. And you do all the operations that are there. So it says next entry, all this thing. It just prints these three things. And as soon as you're done, it doesn't stop. It goes back. So as soon as this is done, it goes back to your for loop starting. Okay. Now the next item in our list. So in our list, we have 3 items, right? So we have B, 0 and 2. The next entry is 0. Okay. The next entry is 0. Now it tries to do 1 by 0. As soon as it tries to do 1 by 0, it raises an error. And what type of error does it raise? You can get it using this function, right? What you get here is 0 division error. Okay, and as soon as you're done, it doesn't do anything else. It runs these 2 lines, which is next entry and these stars, just as a line separator, and then it goes back to your for loop. It goes back to the start of your for loop, and now it tries to do 1 by 2 where there is no error. So if there is no error, so for the last element, right, we have elements b, 0 and 2 in the list. My last element is 2, so it tries to do 1 by 2, which is very perfectly valid. Whenever the try block does not raise an error, whenever an error does not happen in a try block, the except block is not executed. Look at it. When I do 1 by 2, there is no error there, right? So it completely skips the whole except block, directly comes to the line of code that is after that. And it says the reciprocal of 2 is 0.5. Perfect code, right? So except, so wherever there is an error, suppose an error occurs here, it directly jumps to the except block, runs the whole except block, and again goes back into the for loop. That's how try and except work. We'll come to finally a little later in this video. This is very, very important. Okay, now let's see how to, so here what are we doing? We are catching all types of errors within a single except block. But there are 2 types of errors. There is a value error and a 0 error. Probably for a value error, we want to handle it differently. We want to give a message to the user saying, you can't enter characters. For 0, you might want to say, hey, don't enter 0, guys. That's a wrong. You can't, because I can't divide by 0. Okay. In such a case, I can modify my above program as follows. This is my try block. This whole thing is my try block. Right? I can have multiple except blocks. This except block handles whenever there is a value error. This except block is executed whenever I have a 0 division error. This except is when the error is neither value error or 0 error, some other error, it will run the except here. Right? So we can have multiple except blocks. We can have multiple exception blocks. Multiple exception blocks, because we might want to handle different types of errors differently. Now when I execute this is the error you get, right? Whenever I have this, it goes to this and it prints value error. Here it says 0 error or some other error if there is some other error. This is how it's extremely important. Try and except and catch. So in some languages, except is called catch, right? In Java, for those of you who know Java, it's called try catch statements. So since I learned Java before Python, I always remember this as try catch, not as try except, even though I have not programmed in Java for almost a decade now, almost close to a decade. Of course, I understand the concepts of Java, but I never programmed actively. I've mostly programmed in Python because I've been a machine learning scientist for the last decade or so. Okay, now let's understand. Suppose there will be instances where you want to raise an error yourself explicitly. See here, what is happening? Whenever there is an error that happens internally, the Python interpreter is raising an error. But if you want to raise an error, okay, suppose you're running very low on memory and you want to raise an error called memory error. Suppose you want to do that, you are perfectly okay to do it. And you can also give the message that you want. Memory error is anyway a predefined error type, and you can give any message type that you want. So whenever you raise a whenever you raise an error, it will actually tell you what the error is. So I can say there's something called a keyboard interrupt error, okay, which happens when keyboard is interrupted. Like for example, when a program is running, if I say Control C, if I try to kill the program, right, it gives sometimes a keyboard interrupt error. So I can raise any type of error I want at any time in my program programmatically. So here what's happening, there's a difference here. In this case, the error is being raised by the interpreter. When Python is being run, the Python interpreter which is running the program raises the error and says, I can't go any forward. But programmatically, there will be instances where you want to raise the error. Simple example, right? Suppose if I'm writing some code where I have, let's assume I have 8 GB of RAM on my box. Okay, and I don't want my program to use more than 2 GB of RAM. Okay, I don't want it to use more than 2 GB of RAM. So whenever I reach 2 GB of RAM, I want to raise this error and say memory error, and there is you're exceeding the 2 GB limit. Whenever programmatically I want to do it, even though my interpreter will say I have 8 GB of RAM, we have still not reached the memory error. We have ample memory. But I want, as a programmer, I don't want my computer to take more than 2 GB. I don't want my program to take more than 2 GB of RAM. Then I can explicitly raise an error, and I can also give the message that I want. So whenever I say raise memory error this, it actually raises the memory error with the message that I want. Okay, so let's look at some more examples. Okay, suppose imagine this example. Suppose I want you to input a positive number. But so okay, let's look at this code. So this is my try block, this is my except block. Okay, so let's look at what happens here. I'm saying try, input a number, enter positive number, but I've entered a negative number here. Then what I'm checking here, if number is less than equal to 0, raise value error with this error statement. Okay, now as soon as it raises this error, what happens? As soon as an error is raised, it directly goes to the except block. In the except block, I'm handling a value error as E, right? It will print E. And what will it print? The error description or the error message. And what is the error message here? Enter negative number. It's a very simple example of try catch being very useful, where, see, remember here I'm raising the error myself. Here I'm raising the error myself. I'm handling the error myself. And this is a very, very genuine case. If I want somebody to enter rupees that they want to deposit in a bank, if they enter negative number, of course it's a blunder. Makes no sense, right? So error handling can be used to handle errors that, see, a regular program can take negative numbers, but here I want to raise a value error and say this is a value error and you cannot enter negative numbers for bank balance to deposit money into your bank. Okay, very, very simple example. Now, as I promised you, let's look at what happens for finally. So we have learned try and except blocks. There is something called a finally block. Finally block is typically written at the end of all of your try. So if this is my try block, suppose this is my except block, finally is often written at the end of all of these blocks. So this is your try block, your exception block, your finally block. Finally block is run whatever happens. So suppose if there is an error, your except block runs. At the end of all of them, your finally block always runs. This finally clause is executed no matter what, and it's often used to release resources. For example, in my try block, if I opened a file, I did some operations, some error happened, let's assume some error happened. You always want to close your file, right? Otherwise, whatever data was stored in your file is lost. Whatever modifications you have done to your file is lost. So it's always important to close your file at the end of all of your operations, and it should be guaranteed that this will always run. Such type of operations are always written in finally. So as I told you, in our file operations, you should always write your code for opening a file. Here you can perform a bunch of operations that you want. Open your file in a try block, perform a bunch of operations. If there are exceptions, write except blocks. But in the finally block, always write close, so that whatever error happens or anything that happens, your file is always closed gracefully. This is a very, very important good programming habit. This will ensure this is a very, very good programming habit for all of us to learn. Always write any code that could raise errors or that could have errors in a try except finally blocks.